Yeah, madam. Very good evening. Please continue.
Oh, sorry, there is some technical problem. Welcome back, all the participants. Respected Dr. Gunamani Jena sir, welcome to our FDP. May I introduce our next invited talk by Dr. Gunamani Jena. Dr. Gunamani Jena is a distinguished academic and researcher in computer science and engineering with extensive experience in teaching, research, and administration. Dr. Jena currently serving as principal and professor of computer science engineering at Ronald Institute of Technology. His primary research interests lie in signal and image processing with a focus on advanced methodologies such as wavelet transfer and neural techniques. His contribution to academia include authoring 3 books and holding 5 patents. He is a fellow of Institution of Engineers, India, and a senior member. Thank you, sir.
Thank you, madam. Am I audible? Can anybody give a response? Am I audible to
Yes,
you?
sir. Voice is audible. Yes, sir.
Is the screen visible?
Yes, sir, visible.
Yes, sir. It's visible. Yeah.
Very good evening, you all. In absentia, the Honorable Founder Chairman, Mr. Achyuta Samant, the Honorable Chancellor of KIT, Dr. Ashok Parija, the esteemed Vice Chancellor of KIT, Dr. Saranjit Singh, and the Dean of KIT, B. Suresh, all other committee members, and the distinguished delegates from all over the country. I am Dr. Gunamani Jena, Principal of Roland Institute of Technology, Barampur, Odisha. I welcome you all to the 6 days ATAL online faculty development program. And I am privileged to be part of this AICT program organized by KIT, deemed to University, Bhubaneswar. And I have been interested to deliver today's talk on role of reverse engineering on smart manufacturing. Once again, I welcome you all, and also I thank the members for inviting me to deliver my talk. And I am also thankful to the madam as well, the coordinator and convener madam, and also especially Professor Rakesh Ranjan Palai. Dear friends, as you know that the reverse engineering nowadays plays a very crucial role in smart manufacturing. And here in this layout today, I'll be presenting the introduction, the history of this reverse engineering, the recent trends, the types of reverse engineering, what are the tools we are using, the reverse engineering processes, and what are the smart manufacturing and this application of this reverse engineering there, and the various applications, role of reverse engineering in smart manufacturing, what are the benefits, and what are the industries that are benefited or using this concept at present. I can see the very beautiful campus at KIT, and they have for 27 years of expertise. We are thankful to KIT and also thankful to this ATAL program conducted by AICT. Dear friends, so with this brief introduction, I start this topic today, the reverse engineering. As you know, this reverse engineering is the act of dismantling an object to see how it works. This is in general, we understand what is reverse engineering. It is done primarily to analyze and gain knowledge about the way something works, but often it is also used to duplicate or enhance the object. And it is the process of analyzing and understanding the design, the structure, and functionality of a product or system by working backward from its final form. That is the main thing we understand. And it is a very powerful tool that allows us to understand, analyze, and innovate in the face of growing system complexity across industries. Now, it involves taking apart an object or software to uncover its inner working and also understand how it was created. Now, we got some brief idea about what is this reverse engineering. You can see a small diagram in the right hand side. See how this entire process takes place. We look at the physical model rightly available in our hand. Then we go for the scanning, use the 3D scanner. Then we go for the point the cloud data. Then we can plan for the surface model and we can create the CAD readiness, accuracy, and also smoothness. Finally, we go for the CAD computer aided design model and drawing for manufacturing. Finally, we go for the process of manufacturing. So in this small diagram, we can understand the entire process of reverse engineering, how it works. Then we may have some doubt about what is this, what is there in this forward engineering, what is there in reverse engineering. There is a small diagram, we can clearly understand what is this forward engineering, what is this reverse engineering, what is the difference between that one. In the forward engineering, what we do, usually we have the system specification, it is written in the form of some documentations or whatever things are there. Then we start designing and try to implement that thing, that is the design and implementation stage. Then finally, a new system is developed or produced, whatever we say. This is the concept, what actually happens in the forward engineering. But in the reverse engineering, it is the reverse process. That means the existing system or the software, whatever things we bear in our hand, from this we try to understand and go for the transformation and we go for the re-engineering of the system. Clear? So this is exactly what we do in the forward engineering, the reverse things we try to do in the reverse engineering. Then, if this reverse engineering is completely new concept or it existed, so for this, let us have a look at the history of this reverse engineering. If you minutely observe, this reverse engineering has been around for centuries in various forms. It is not a completely new. However, it gained significant popularity during the 20th century with technological advancements and the rise of industrializations. So at this moment, so it is gaining the momentum. That's all. Otherwise, it is not a new concept. It is there for centuries. In the early days, reverse engineering was primarily used in fields like manufacturing and engineering to understand how machines and mechanical systems operated. It allowed engineers to study existing products, to improve upon them, and create compatible parts or develop similar products. That is the main thing they used to use this reverse engineering process, and we're getting some insight on that one. If you closely observe, during the World War II, reverse engineering was crucial in examining captured enemy technologies to gain strategic advantages. And with the advent of computers and softwares, reverse engineering shifted towards understanding and modifying software code. And especially in 1970s and 1980s, the organizations began reverse engineering proprietary software, create compatible versions, or discover vulnerabilities and security flaws. So these are the things I'm talking during the 1980s. So this led to the development of ethical hacking and security testing methodologies where experts would examine software to identify weakness that malicious actors could exploit. These were the things we study, just like the literature study or literature review, whatever we say. What are the recent trends? Recently, The reverse engineering has become more prevalent as both hardware and software have become increasingly complex. And it is now commonly used in various industries, including automotive or automobile, whatever you say, the aerospace, electronics, and consumer goods. Why this is not the only things? There are a lot of areas where we are using this reverse engineering. However, it's important to note that while reverse engineering itself is legal, using it to infringe on intellectual property rights, such as copying patented products or proprietary software, it is illegal in many jurisdictions. That is the things we have to remember while you are using the reverse engineering. Then, one thing comes to our mind: what are the different types of reverse engineering exists? Reverse engineering, it is a multifaceted process with different approach depending on the goal, but with two main types. So one is the static analysis, second one is the dynamic analysis. What is there in the static analysis? Let us have a look on that one. The static analysis involves examining a software system's code without executing it. I'm not going to execute the code, but I want to examine what are the variables used, what are the code, how it is working, all the things I want to check it here. So it allows engineers to see how the code works, identify the vulnerability, and understand its structure. These are the things we can do using this static analysis. And with this static analysis, experts analyze the binary or the source code to extract information about variables, functions, and the control structures, and more. So this, you can say, the first type of reverse engineering, that is the static analysis. Then while you go for the dynamic analysis of this reverse engineering, this dynamic analysis is another type of reverse engineering that involves examining a system's or software's behavior and functionality while running. See, there only we are going for the static part, examining. Here we are bothered about how it behaves or how it works and what are the different functions. That's why the system's behavior and functionality, we can test it here while running with this dynamic analysis. That is the thing. Unlike static analysis, which focus on the code itself, dynamic analysis looks at how it behaves in the real time, all the real-time applications. So this type of reverse engineering allows the researcher to understand how different components interact, identify vulnerabilities or bugs, and identify hidden functionalities. And during this dynamic analysis, various techniques are used to monitor and analyze the execution of a program. So this is only I'm focusing related to software field, but everywhere the function is same. So we can go for a model, but we see how it behaves or how it works before the actual manufacturing is done. That is also done in this dynamic part. Then what are the common approaches we are using for this reverse engineering? One common approach is runtime monitoring, where tools track the input-output data flow and control flow within a program. So this is related to software I'm talking about. This helps researchers understand how information moves through different parts of the system and how it impacts its overall behavior. I told you that we are not confining to the static approach. We are static part. We are also going for the dynamic. So that's why the data flow and the control flow both are important for us. And this dynamic analysis also includes techniques such as debugging, profiling, and tracing to gather more detailed information about the software's executions at runtime. You try to understand it is during the runtime. That's why I'm focusing it the dynamic. And by analyzing the dynamic aspects of a system or software, experts can uncover valuable insights that may not be apparent from the static analysis alone. Here, that is the reason both static and the dynamic analysis both are important to us. See, let us see an example here. Here, there are steps involved in reverse engineering of food products. Suppose we are going for a food product. What are the steps involved there? What you see, I have numbered it 1, 2, 3, 4, 5, 6. This is not the photos developed. It is taken from some sources. So I have not quoted it here, but it is also a rating. Here, first we select the food product. What is the food product I'm going to manufacture or develop, whatever things are there. Then we gather information specific to that product. So first one is select the food product. The second step, we gather information specific to this product. In the third page, what do you do? We recreate the product. In the fourth one, test the product and make any changes if necessary. Fifth one, go for the documentation or document the procedures, right? Six, validate the results. So this is the different steps that are involved in the reverse engineering for any product. I have given a food product example. You can take any other example. The same thing happens there also. Then what are the different tools used by reverse engineering to do all things? We have a number of reverse engineering tools used, but some of the important things we'll discuss, that is the RIGI is the first one. This RIGI aids reverse engineering by allowing user to visualize the relationship between various system components. There are different system components, and what are the relationships exist between the components that we can visualize using this one. And by representing them, connections as nodes and edges on a graph, just like you have seen a graph, the circular nodes will be there and the connecting edge will be there. In the similar manner also you can represent. By representing their connections as nodes and edges on a graph, Rigi provides a clear picture of how different elements interact. So the main purpose is there how the interaction takes place. That is important for us. Additionally, Rigi enables users to navigate large code bases or databases efficiently. Okay. Then the second type of tools we are using, CIAO. Okay, some shortcut is there. This is a graphical navigator. This CIAO, it is a powerful tool that help engineers and developers gain a visual understanding of complex systems. With this CIAO, we can navigate the different components and their interrelationships within a software or hardware system. And this allows them to identify dependencies. You understand the correlation or dependencies, and understand the data flow and analyze the control structures. Everything we can observe it here using these tools. Similarly, I told you that there are a number of tools. Another tool is the PBS or the portable bookshelf. Portable bookshelf. It provides engineers with a comprehensive library of information and also resources. We can easily access manuals, data sheets, specifications, and other relevant documents for the product or system they use or they are using the reverse engineering. And the portable bookshelf eliminates the need to spend countless hours searching for information from various sources, because gathering information is also part of these things. So you have to search here and there, but this PBS provides all the things there. So we need not spend a lot of time in searching or Googling. Then another is the IDA Pro. This IDA Pro, this is also one of the widely used tool to analyze and understand binary files, making it an essential asset for security researchers, malware analysts, and also software developers. And with its advanced disassembly capabilities, IDEA Pro, it allows users to delve deep into the code structure of a program or a system. Additionally, it supports multiple processor architectures and can easily handle complex binaries. So, like that, we have another is the slide there. So this helps break down complex code structures and extract valuable information. See, if some complexity is there because number of functions is there and the line of code is growing, in that case, we can use this type of tools which can break down these complex code structures and extract valuable informations. One of the key functionalities of this Scala is its ability to identify and recover functions names, making it easier for reverse engineers to understand the code's logic. Additionally, Scala provides an intuitive user interface. Try to understand this word, intuition or intuitive user interfaces, making it convenient for an analyst to analyze and visualize program flow. So these are like that. Also, we are having some other tools. Now, let us understand what is this reverse engineering process. Now you understand what is reverse engineering, what are the tools we are using, and let us understand what is the reverse engineering process. What happens here? You see, the reverse engineering it is just like a systematic process that involves dissecting and analyzing a product or system to understand its inner working. This is the gist of this reverse engineering. And this process consists of several key steps, and each is crucial in unraveling the complexities of the subject at hand. You look at the picture here on the right hand side. I have taken this from this Spacey Works. So this is the things I have taken picture from there. So this is the product or system. We go for the pre-screening, then you do little research on that one. Then you go for the disassembly and information extraction. Then we go for the reassembling, then the product development, review and documentations. Finally, go for the modeling. If you see the initial page 1 or 2, whatever the pictures have, more or less it is also related to that one. It is in a different uh, way, a different naming. They have given all the things. So this is the entire reverse engineering process. For you go for a product, you go for a software development, you go for any type of manufacturing or things. Now, as I told you that we have a number of things. First, the product system pre-screening. So let us discuss one by one. What is there in the product system pre-screening? What is the research part we focus? What is the disassembly and information extraction? All the things you try to understand these things. We have a system in your hand, and we are going in a backward process to gather information, and you have to go for the reassembly, or you are going to duplicate, or whatever things are there, or you are going to modify that one. Now, in the first one is the product system pre-screening. This initial step, it sets the foundation for the entire process and ensure us are on the right path to uncover valuable insights. And during these pre-screening phases, we carefully examine the product or system we want to reverse engineer. So you can understand pre-screening means, you see, it is just replacing what is there, and we try to understand that. Okay? And we carefully examine the product of the system we want to reverse engineer. It involves studying its components, its function, and the overall structure. This is the what we call. That means what is there existing that we want to go for the study, we go for the understanding of that one. By doing so, we understand how everything works together and identify any potential challenges that may arise during the reverse engineering processes. This is what exactly we do in this product or system pre-screening. Next, product system pre-screening also allows us to evaluate whether reverse engineering is feasible for you or for the specific project, and you can assess factors such as the cost effectiveness, availability of resources, and expertise required for success reverse engineering. For example, suppose you got a just like F-16. Even if that is there and it is landed or it is available with you, see that one. So what are the components you are using? What is the technology you are using? So it is not feasible to prepare in a country where those parts or where those specific materials are not available. Okay. So this is the thing in the pre-screening stage, we can go for all things. We go for all the factors carefully examine. First one is the cost effectiveness. Suppose the original cost is 10 crores. By reverse engineering, if the cost is 20 crore for you, then what is the fun of doing that one? It is available for 10 crore and you are spending 20 crore to do that one, the meaningless. Then ability of the resources. Suppose we need some uranium 235 and it is not available to you, then how will do that one? And expertise required, say what is the technical know-how or what is the expertise required for that one. If it is not with you, then even if you do the reverse engineering, even you gain all the information, still you cannot do. Okay, that's why these are the things it is done in the product pre-screening stage. Then we go for the research. So once the pre-screening is complete, that means we gained some information about the product. Next step is the reverse engineering process is research. We do some research. Okay, research. We try to find out what is the pros, cons, what are the modification we can do, what is the enhancement we can do, or what is the feasibility of that one. So this crucial stage involves gathering as much information as possible about the analyzed product or system. We just analyze the system and we try to gather more and more information on that one. It is the things we say, it is the research part we involve here. And during this phase, engineers delve into various sources to acquire knowledge, including technical documents, patents, user manuals, and any available documents or documentations related to the product. If any such things is available, people have to study that one. They have to go through that one. That is done here also during this research process. They also conduct online research and may even research out to experts in the field of additional insight. See what are the online materials are available, videos are available, or documentations are available, or who are the experts available, they can take their counseling or consultancy. So using all the things they try to do, and this part is mainly the research part. Third is the disassembly. Once the initial no first part pre-screening is over and the research is over, then we go for this third, that is the disassembly. Means just we divide it into small part, right? Once the initial research is complete, the next step in the reverse engineering process is disassembly. This involves breaking down the product or system into components to understand how they are interconnected and how they function together. See, it is just like we got a small calculator, we try to open everything, and we see what is that, what is the IC, what are the battery, all the parts. Then we can reassembly. By this, we can understand how the components are related, how they are fixed, and how they work together. This is exactly what we do in the disassembly. And during the disassembly, experts carefully take apart the product while documenting each step and noting any observations. So it is not like that you open everything and you don't remember how to assemble or how to bring into the original form. Then it is just like breaking. It is not disassembly. And this meticulous process allows them to understand the product's inner working better and identify key elements for further analysis. Some reverse engineering tools can automate the disassembly process for software products, while physical products may require mechanical disassembly. That means you see software case is different thing, but while you are going for a product or which are the mechanical related things, then it needs very expertise in that area, and also it's must be properly recorded what you are doing. The reverse process we have to also do in the reverse manner, right? Then in the information extraction, see, before the information gathering, we have to extract the information, what information is there with the system or in the internet or with the expert. We have to extract that relevant information for our further modification. Once the disassembly process is complete, the next step is information extraction. This step involves gathering meaningful data from the disassembled components. This is called the what is information? A meaningful data, we call it as information, which is useful to us. And during this stage, various techniques are employed to record and analyze different aspects of the system or product being reverse engineered. And this include what are things we want to do? The recording of this functionality. What are the functionality of this product or the system? We go for the recording. It involves capturing the behavior and functionality of a system or software to understand how it operates by recording the system's interactions, inputs and outputs. Okay. Second thing, recording the data flow. This step deals with the data collection, analysis of the data, and also movement with the system or product. By understanding how data is processed, transferred, and stored, engineers can get or they can study and get a lot of insight for these things. Right? Then the next one is the recording the control flow. First one I have shown the data collection and the data flow. Next we are going for this recording the control flow. See, you understand the difference between data and control. Say data is say 5 and 6, and some operation you give 5 plus 3. Control flow, first you add, then you multiply, then you do. It gives some control, or you have to do that one, right? So recording control flow, this process helps understand the logic of the program's execution, allowing for further analysis and modifications if necessary. So you can understand what is the control, what is the next step, what to do, how somebody controls you like that. We write some algorithm or something that it will control the entire thing. So by visualizing, mapping out of this control flow, reverse engineers can trace the path of logic to different parts of the code, enabling them to identify potential points of failure or areas that could be optimized. Right? And first I have gone for the disassembly. Now we are going for the reassembly, right? Once all the information have been extracted or has been extracted and analyzed, the next step in reverse engineering is the reassembly. And during this stage, the reverse engineer puts together all the dissected components of the product or system to recreate the original form. Get it? Now, reassembling involves carefully fitting together each piece, ensuring they are correctly aligned and connected. Simply putting, it will not function because all the connections should be proper or all the things properly integrated. Then only it will function, right? So this step requires precision and attention to detail to ensure that every part is properly fitted and functions are intended. Otherwise, it will be just like breaking that system. If you are unable to reassemble, then you spoil that system. It is that. A reverse engineer learns how it was originally designed and constructed by successfully reassembling the product of systems. So what is the process of the reassembly? Because we got the system, we did the research, we gone for the all collecting all this information, this assembly on we have done. See, up to this it is okay, and we are able to now manufacture the parts or whatever things are there. After reassembly, suppose it doesn't work properly, then what is the fun of doing all the things? Then whatever the things we disassemble, now we reassemble. See, there may be some problem, there may be some connection flaws, some problems. If we can rectify all the things, then whatever the parts we are going to manufacture in future by the reverse engineering, that also works fine. Okay, that is the idea, right? Then we go for the next part, that is the modeling. So once all the necessary information has been extracted and analyzed, the next step reverse engineering is modeling. So you know what is a model and why do we model and what is the purpose of this model. Right? So this involves creating a detailed representations of the product or system being studied. And in this phase, engineers use specialized software tools like the CAD or the computer-aided design to create virtual models that accurately depict the original design structure, behavior, or functionality. That is not only for modeling, physical modeling. Also, we can go for the behavior or the functionality that is there. If that part is there, then that what we call exactly the simulation. Okay. In the simulation, it is not only we are going for the physical part showing a car. A car is also running, or it is also going with a speed and all things. The simulations you are exactly doing. So these models serve as blueprints for understanding how the product or system works and can be used to identify any flaws or improvements that need to be made. By developing accurate models through reverse engineering, engineers can gain valuable insights into complex systems and make informed decisions for future development projects. To understand? So I think the people who have knowledge about this modeling, either in the software engineering or some part of this mechanical engineering, they can clearly understand because before going for this actual product, we go for the modeling, which is a small version of that one. It can be a virtual one also. We go for all the things, how it looks, maybe the appearance part, how it functions, maybe the behavioral part, and its efficiency, everything we can, all the testing part also that we can do using this model, right? Then finally, we go for the review. This crucial step involves carefully examining all the gathered information and ensuring nothing has been overlooked or misunderstood. And during this review stage, engineers meticulously review each pieces of data collected during information extraction, disassembly, and also modeling. All the different phases, whatever the information or data is collected, everything is meticulously examined. That is the idea. And they check for accuracy, they check for consistency, and the completeness, ensuring they clearly understand how every component functions within the systems. That is the main thing. We do it in the review part. This careful scrutiny helps identify any discrepancies or gaps in knowledge that may need further investigations or clarifications. That is the purpose of this page review. Finally, you go for the documentation. Still now, what you have done, you can go for the documentation. Why documentation is important? Say what you did, you know, or you understood. But if it is documented, then anybody go through the documentation, he can also understand. That's why this documentation part is very important. So once all the necessary information has been extracted and analyzed, it is essential to document everything for future references and also understanding. This step involves creating detailed reports, various diagrams or drawings, and documentation that captures the finding and insights gained during the reverse engineering process. Right. So entire thing is documented or written in the soft copy or hard copy, whatever things are there, it must be recorded. And this documentation should clearly explain how the product or the system works, highlighting any modifications or improvements made during the reverse engineering process. And it should also provide instructions on the reassembly or reproducing the product if needed. Entire thing should be there, clearly, neatly explained. And this documenting any limitations or challenges encountered during the reverse engineering can also help others to avoid the similar type of issues. Suppose you face some problem, it should be documented also there so that the next person working, he will not face that type of problem while doing this similar type of projects. Then is the product development. So during this stage, engineers can identify and weakness or areas of improvement in the original design and make necessary modifications. Suppose you see, all of you know about the review of a paper or whatever we are saying. We are writing some review papers, isn't it? So existing paper is there and you studied and all things are. Then what you do? What are the enhancement can be done? So using that also you go for that one. So here also, if any improvement can be done or any future scope is there, that can be studied and that can be added there. They can also use the knowledge acquired during the reverse engineering to enhance features, functionalities, and performances. For increasing your enhancement, improving or increasing, whatever you say. By leveraging reverse engineering, findings, product development, team can create innovative solutions that meet market demands while ensuring compatibility with the existing systems. So these are the things we come across. Then we come to the second phase, what is our smart manufacturing, right? And then we'll go for how we correlate with smart manufacturing with the reverse engineering. So till now, we studied about the reverse engineering, which plays a crucial role in the smart manufacturing by enabling the development, optimization, and integration of advanced product techniques. So here four things are there. One is the development, one optimization means out of a number of solutions, finding the best solution, that is optimization, and also integration of advanced production techniques. What are the techniques are there, technologies are there, how we can integrate or how we can use there to get better product. So it involves the process of deconstructing an existing product or system to understand its design, functionality, and operations. Here's how reverse engineering contributes to smart manufacturing. Now let us study what are the things it contributes to smart manufacturing. First one, I think already some session is already done on this digital twin. I think one professor has taken a session there from this schedule I have gone through. It is there. This digital twin creation, reverse engineering, it is instrumental in creating the digital twins, that is the virtual replicas of physical assets used in smart manufacturing. So I'll tell you one thing. I think it is not only confined to mechanical engineers, the delegates, whatever I've seen. There are people from different branches also. You might be knowing nowadays some IITs they are creating some virtual labs like that. Even if the chemistry lab also virtual, it is done. So you can take some part of sulfuric acid, some part of nitric acid, some part of and you can mix it. Flame is coming, a fume is coming, some solution color is changing. So this is the virtual things. It is not the actual things. Actually, it is no LCD is there and nothing is there. But all the effects, the color change, everything is looking like that. This is the virtual replicas of physical assets used in smart manufacturing. By capturing detailed 3D models of existing products or machinery, manufacturers can simulate, monitor, and optimize operations in real time. So this is, I think, this is another area of talk. I think they already it is delivered regarding this digital twin. Just I'm telling, yeah, we can also do this here. Then the legacy system integrations. Many manufacturing facilities operate with the outdated or legacy equipment. Reverse engineering helps in understanding and digitization of the old systems. So creating some 3D CAD models for parts that lack original design documentation. Suppose some parts, the original design documentation is not there. So using this 3D CAD computer-aided design, we can model, okay, and we can also try to redesign. Then integrating legacy systems with modern IoT-based solutions to enable the Industry 4 capabilities. We'll see, I think we have a session related to on this Industry 4, Industry 5, and also their integration in the smart manufacturing, maybe 21. I'll be delivering the session there, where we discuss all the details. Then the various applications. The reverse engineering is important in industries from military applications to software and mechanical engineering. Some of the few examples will give it, but there is a lot of areas, a lot of applications where you can use this reverse engineering. See, one is the military applications. This you can better understand if people they know what are the military equipments in China. They will have the better understanding about these military applications. By reverse engineering captured equipments or weapons, military forces can gain valuable insight into their adversaries' capabilities and improve their defense strategies. So military experts can analyze and understand how enemy technologies work together or work through reverse engineering. This allows them to identify vulnerabilities and weakness that can be exploited during the combat operations or used in the development. Some all these type of things, right? So let us have a look. You see, it is not for any offensive. It is only for the knowledge sharing. Please, the audience, I take request you not to take it otherwise. So the important is the design copy. See, this you can clearly understand because here I have not named how the Chinese defense people they have made the design copy. You can see this is the original. You can see at the bottom, and the copied one you can see in the top. So like that, you can see it here how the Chengdu J20, you can see in the left hand side, that is out of the F-22 Raptor. You can see. So the details I have not given for some issues. So you can get it from internet or anywhere. You can check all things. So you can see the ditto copy. They are able to do it using the reverse engineering. Here also Chengdu J10 II. That is the substituted F-16 fighting Falcon. See how they have done. So similar type of models with functionality, they are able to do this type of things. Here you see the Shenyang J11 and 16 from the Sukhoi 27. Sukhoi, these are the Russian products. You can see and how the Chinese are able to do using the reverse engineering. Similarly, the Shenyang J15 from Sukhoi Su-33, the latest thing, you can clearly see how they are able to do. And it is really, they are able to do all the things. And here you can see, even if the American F-16, they are able to go for the reproduction using the reverse engineering, like JF-17. See, that is the Jalong or JF-17 Thunder. That is out of both that using the MiG-21 of the Russian base and also the American F-16. So you can clearly understand what the applications of the military applications using this reverse engineering. Now, let us look at some of the medical applications. Uh, just a minute. And some of the various medical applications also we come across. Yeah. So by reverse engineering, the complex interactions between the genes, the scientists can decipher the intricate mechanisms underlying diseases and identifying the potential targets for different therapy. Right? And the reverse engineering allows researchers to unravel how genes interact with each other and how these interactions influence the various biological processes. That is the things we can use in the medical applications, like the scientists can gain insights into disease progression and drug responses and even predict patient outcomes also. And this knowledge paves the way for targeted therapies. You have a diagram here. See the CT scan or the CT data set we are having here from the 3D scanner. Here the 3D reconstruction model. See the CT scanner, it is a two-dimensional, just like a picture you can see. By putting one above another, we can put the 3D reconstruction model. Then we can implant the design using the reverse engineering. Then we go for the rapid prototyping. Then we go for the rapid prototype model of the skull. Okay, the skull plus implant. Here also are putting here the PMMA implant. So all the things we can build together, everything. You can see what is the input here. Input I have given a city scan, a data set it is there. What is the output here? We are able to get the type of things there, right? Then we come across with the software engineering. Reverse engineering plays a crucial role in software engineering, especially when the source code is lost. See, there are so many things are there. No, you see, you are launching projectiles or the missiles, etc. Sometimes the code is very confidential. Maybe it is lost also. When it is lost or when it is not available, we can use this reverse engineering to especially redo it. The reverse engineering plays a crucial role in software engineering, especially when the source code is lost, original code which was written, if it is lost, then using this software engineering, we can do it. I think the people who are here, if some computer science people are there, we have a subject like the unified modeling language. That is, of course, part of this object-oriented analysis and design. So that is the UML or unified modeling language. What is done here, I'll tell you one thing. Similar type of things there also for the electronics and communication people, that is the VLSI. Okay. So this is the software related, that is the UML, that is the hardware related, it is the VLSI. Okay. So you can go for the different chips, integrated chips, etc., designing everything, the simulations you can do there. What we do here in the unified modeling language, previously we are writing some codes, we are running, we are developing C. But here, what I am doing, I am neatly drawing a number of diagram, and from the diagram, I am able to generate codes. Try to understand, again, I'm repeating. In the unified modeling language, I am drawing a number of diagrams. Maybe it is a use case diagram, maybe it is a class diagram, maybe interaction diagram, maybe component diagram, deployment diagram, different type of diagrams are there. And there are techniques to learn. It is not that difficult. Anybody without any coding knowledge also, they can understand, they can also learn it. And once you understand the basic concept for any documentations you are having or for any scenario you are having, using that scenario, you can generate a number of diagrams. I'm talking about the use case diagram, I'm talking about the class diagram, and other type of diagrams. And in the place of a button, a code can be generated not in one language, in number of languages. You can generate code in Java, you can generate code in Python, you can generate code in R programming, you can in C++, anywhere you can do all these. So that what I want to say, that is exactly they are using the concept of forward engineering, reverse engineering there also. Why I'm telling, why you can ask why sir you are giving that example here. There is also a concept of forward engineering and reverse engineering. So generating a software or generating an application software from the code is the forward engineering. But here what you are doing, from the diagrams you are able to generate that one, that is the reverse engineering. Okay. We can say backward engineering, we call that the reverse engineering, right? So in such situations, reverse engineering allows developers to analyze and understand the functionality of an existing software system. When I say for a model, when I say for a system, for a software system or software application system, the same process is same. When the reverse engineering also aids in extracting algorithms, data structures, and design pattern from legacy systems, which can be used in future projects. Okay. So these are the things we keep in our mind that like that, and number of applications there. Say we can look for this mechanical engineering. When a mechanical device malfunctions or breakdown, reverse engineering can help understand the inner working and identify the root cause of this issue. Why the issue happened, why it is malfunctioning, or what are the reason behind that one. That we can also do. By carefully disassembling the appliances and analyzing each component, engineers can understand how it was designed and how it was manufactured. Okay, this knowledge allows them to pinpoint any faults or defects that may have contributed to the problem. And this reverse engineering also plays a crucial role in ensuring product safety and also the reliability. By reverse engineering, faulty equipment engineers can uncover the potential design flaws that could do some of the incident to failure, right? Then there are so many things are there. Say some parts, replacement of some parts. Some parts is not available. The model is outdated, or it is like that. So many. Why you are going for that ones? For example, so you have taken a computer related things. You have taken a sir, maybe Nitro 5. For 1 or 2 years, they say product is outdated. And some part you already purchased for the 95,000. This product is outdated means what? You will throw that $90,000. So it is possible to have some replacement of the part, and that is also done. You will be astonished that in New Delhi, number of parts are reproduced using this reverse engineering. The quality we compromise, it may not be as the original. Why you are going there? You see, for a printer, whatever the cartridge you are using, we have substitute things for that one. For everything we are having, that is, they are using the reverse engineering to that one. And the various parts for the servicing or the repair, the failure analysis, parts improvement, anything can be done, and the diagnostics and problem solving, all things are there in the servicing. Then we can use this for the rapid prototyping. Prototyping, as you understand, a small model with the functionality and all things, we call it as a prototyping. For example, say, suppose I go for manufacturing the Mercedes car, and it is the first time I am manufacturing. Previously, Mercedes is not there. It is there. I'm just giving an example there. So I have money. I spend the money and do some design and go for a manufacturing of that one. And the customer don't like that one for so many reasons. Then what I have to do? Already I spend money. Then what I have to do? Will I go for the push sale of that because Mercedes car is there in not in lakhs? It will be in crores, no? So before that, what I do, I go for a prototyping of that one. So it is the look or the model, with the functionality, with the various type of testing, everything I do in the prototyping. If it is successful, then I take the reverse, the feedback, I take their day-to-day things, and I involve all this feedback process and everything. Then when the product comes out, then it is easily accepted in the market. That is the thing. We always go for a prototype before going for this actual product. This rapid prototyping and also the customization. Here, the reverse engineering supports the development of prototypes by providing accurate model of components for redesign or reproductions. It enables mass customizations by tailoring products to individual requirements using the scan data. Right. Then we go for the supply chain optimization or the SCO. SCO or the supply chain optimization. What is this supply chain? You better understand. Only this optimization part that I will focus it here. So here it allows manufacturers to analyze competitor product to identify design improvements and cost saving opportunities. Two things are there. How we can go for the improvement and how can save the cost. Suppose what you are manufacturing cost is 20 rupees. If I am able to develop with 15 rupees, then definitely I can mold the market or I can sell my product there. So then the reverse engineering can replicate components to reduce reliance on single suppliers because if somebody is no, it is happening now. So suppose I want that particular engine from USA, they stop. No, okay, no, for the timing we cannot supply you. But I am on wire and there is a wire and I need that engine. Then what I have to do? And I have to wait after 5 years when wire is over, we are depleted, they will provide that engine, that engine. What I have to do is that one. So this reverse engineering can replicate components to reduce the reliance on single suppliers. Suppose USA is the supplier, and at this moment, the time of need, he stopped supplying, then I am in trouble. You try to understand. So using this reverse engineering, I will try. India is doing that one. They're able to do or respond to supply chain disruptions, right? So this is the supply chain optimization. Here also you can do the reverse engineering. You see it here, about something it is here. If you see it here, the reverse logistic, here something, the distributor is there. Here the industry is there. From the industry, the distributors are there, the retailers are there. Then the remanufacturing is done. The end user also they can use it. Okay. So this is the entire process, the rotation, the cycle. You can see here also it contributes to the supply chain optimization. Then another important thing, study number 5, that is the predictive maintenance. The predictive maintenance, it is by reverse engineering critical parts of equipment, manufacturers can anticipate wear and failure patterns. It helps implement predictive maintenance strategies, reducing the downtime and also optimizing the assets life cycle. Okay. So this is related to the maintenance which I can predict in advance. Okay. So and also I can get prepared for that one. Then the quality control and also the process improvement. Reverse engineering aids in verifying that manufactured parts meet quality specifications by comparing them to their original designs. See, so using this reverse engineering, I developed something, and I have the original. We can go for the comparison by the various no test. I can go for the on that one. I can go for the comparison of the efficiency, the cost, everything we can compare it. Right? And also I can check the quality and also the process improvement. It identifies manufacturing defects or deviations, ensuring consistent product quality. This also helps in this one. Next one is the cost and time efficiency. You see, for any product, the important thing is the cost as well as uh, the research we put behind that one. For example, that once upon a time Motorola mobile phone was holding the entire market. You get it now. Then where is that? Is there in the market? Why it is not there? Is it a bad one? It is a very good one. Once upon a time it is dominating the entire globe because they could not spend much money and time for this research. So they could not go for what the customer wants. They have a good model, they have a heavy model, they have a big model, but that is outdated. And also the cost and the time efficiency. It eliminates the need to start from the scratch. See, if you start from the scratch, it takes a lot of time. It takes a lot of time to develop and a lot of research to get up to date or updated. So if you are having things with you and just you try to understand, you go for the improvement or enhancement, you save a lot of time. So it eliminates the need to start from scratch when designing parts, they reducing the development timelines. See, if you start from the scratch, obviously it takes a lot of time because you have to understand, you have to develop, you have to test it, you have to rotate in the market, and it takes a lot of time and money also. It reduces cost by re-engineering expensive or obsolete parts. Some expensive parts, if I go for, you see, so many companies, the original product is less, but while you are going for the servicing of the spare parts cost sometime it will be equivalent to or nearer to the cost of the original product. So that creates because it is a monopoly. They know that these parts or the things are not available outside. Whatever them they claim, the people have to give it. Otherwise, the system is gone. Then the knowledge retention. The captures and preserves design data for critical parts, safeguarding the knowledge in the event of theft, turnover, or loss of documentations. So this is also very important. Suppose some expert is there, he resigned, your company joined in another company. And if proper knowledge retention is not there, then entire thing is gone. In this context of smart manufacturing, reverse engineering synergizes with advanced technologies like the 3D scanning, artificial intelligence, and also the machine learning, different algorithm to enhance productivity, flexibility, and innovations. These are the things. Then now the important part or the very interesting part of our talk today, that is the role of reverse engineering in smart manufacturing. Now you can start. If you want, you can have a 1 or 2 minute break. I'm not the authority to declare all the things. Or if somebody gives a comment, we can continue. Then we can also continue.
Sir, we can continue.
Fine, fine. Thank you, madam. We'll continue. Then we focus on this role of reverse engineering in smart manufacturing. Now, till now, you understand what is reverse engineering, what are the different tools you are using, what are the process, and what are the other concept. Everything now you understand. And what is this smart manufacturing also understand. The role of this reverse engineering, this smart manufacturing is very important, and it is actually the concept of today's this talk. Reverse engineering plays a very significant role. I think you are able to see the screen. Can anybody please give a comment? Are you able to see the
Yes,
screen?
yes, sir.
Sir, please keep it in
Thank you.
sliding mode, sir.
Yes, 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 sir. Yes, sir. Thank you. Thank you. Thank you. Yes. Is it okay, sir? No? Is
Yes,
it
sir.
okay?
Yes, sir. Yes,
Yes,
sir.
yes.
Thank you,
Thank you.
sir.
Thank you, sir. Thank you. Thank you very much. So this reverse engineering plays a significant role in smart manufacturing by enabling the companies to analyze and improve existing products, processes, and technology. You think what is the product, what is the process to do that one, what is the technology you are using to get that product. Here are several key aspects how reverse engineering contributes to smart manufacturing. Part one is the product improvement. By disassembling and analyzing the existing products, manufacturers can identify the design flaws, what are the defects or other things are there, the inefficiencies with the existing systems, and the areas for enhancement, where we can enhance, where we can improve. This iterative process can lead to the development of more efficient and effective products. So this is the role of reverse engineering in the smart manufacturing, one of the key. Next, the competitive analysis. Reverse engineering allows companies to study competitors' product. Suppose one product is available from iPhone, one is available from like this one. We analyze, okay, study the competitors' product, understand their features, and develop strategies to improve their own offerings. What is the features available in other system? What I am offering, where I can improve, I understand that. This can lead to innovations and differentiations in the market. Because in the market, with the same price, if a product is available with so many features, people are the youngsters, they will definitely try to purchase which is having the more features. You must be updated. Then the legacy system integrations in smart manufacturing, integrating modern technologies with legacy system is often necessary, and the reverse engineering can help understand the functionality of older systems, allowing for better integrations with smart technologies and IoT devices. As you know, this Internet of Things devices. So different devices with the different scanners and different IP address, and using this IPv6, they can collect the data, the information through various sensors, and they can integrate, they can communicate, they can send and receive things are there. Then the okay, the rapid prototyping. Reverse engineering aids in the rapid means fast, rapid prototyping of components and systems by creating digital models from physical parts. So you see, people will be knowing, no, who are using, say, for example, who are using the Rabbit tool for designing. So you can do the multi-story building, all the apartments design, all the 3D with all the furnitures, everything you can do. That whatever things is that before the construction you can see how it looks. You can go for the plantation, you can have a car in front of that one, you can put all the furnitures of your choice in different rooms, and you can check whether it fits there or not. Everything you can do it. So with the rapid prototyping, the physical parts, manufacturers can quickly iterate design, reducing time to market for new products. That means whatever the time it takes to be available in the market, that time is reduced. Then the cost reduction is another thing. Understanding the components and materials used in existing products, it can help manufacturers find cost-effective alternatives. It optimizes the supply chains and also reduces the production cost. So these are the some things. Again, the quality control. Reverse engineering can be used to verify the quality of parts and assemblies by comparing manufactured products to their original specifications. Manufacturers can ensure consistency and adherence to quality standards. That is the things it is coming under the quality. Because what is the quality in the original? I want to maintain the same quality. I want to stick on to the quality. I never compromise on the quality. Then the customizations and personalizations, manufacturers can use reverse engineering, create customized versions of existing products. Okay. Say a company is offering a product, I want to be customized according to my requirement. I want to change here, I want to change that. It's called customizations. And based on this customer feedback or specific market needs, personal needs, whatever things are there. This flexibility is crucial in the age of mass customization, right? So that's why the customization and personalization is very important while you are going for this using the reverse engineering for the smart manufacturing. Then knowledge preservations, reverse engineering helps preserve the knowledge about older products and technologies, ensuring that valuable insights and designs are not lost even when the original designers or manufacturers are no longer. So this is that means the knowledge, old and new, both are preserved. Then training and skill development, analyzing existing products and systems through reverse engineering can serve as a valuable training tool for engineers and technicians, helping them understand complex systems and improve their problem solving skills. Okay, so this helps in the training and skill development, right? So next is the sustainability initiatives. Reverse engineering can support sustainability efforts by enabling manufacturers to analyze products for recyclability and material usage, leading to more environmentally friendly practices and designs. See, the sustainable means you can go for the manufacturing, you can go for mass manufacturing without affecting or impacting the nature or the environment. It's called sustainability, right? So we have to you go for the mass product, you use the resources, use the electricity, but if you can go for the different type of technologies, advanced technology, or the different type of energy saving things without impacting the environment, that is better. That is the sustainable initiatives. Then what are the benefits of this reverse engineering smart manufacturing? Okay, here are the few benefits of the reverse engineering while you are going for the smart manufacturing. First one is the enhanced product design. Say we have the existing product and we have analyzed and we have understood if there is a scope or space for the enhancement, we do it here because the product is not ready with us now. We are going to redo that one. So if any improvement is there, we do it there. That is the improvement on this existing product. And improve existing products by identifying design flaws or areas for enhancement. This leads to innovative designs that meet customer needs more effectively. Then after time to market, as I told you that if you start from the scratch, then it takes a lot of time and takes a lot of time for the testing, then putting to the market, getting the feedback and doing all things. But when we are going for the reusability or the existing thing I'm using, but not exactly copying their intellectual property right and everything. But I have my contribution, I'm modifying, I'm going for the enhancement, but I'm not starting from the scratch. So this leads to time to market is reduced, less time it takes. So rapid prototyping enables quicker iterations and refinements based on the feedback. Refinements, some improvement you do. Then the cost efficiency, reverse engineering can help identify more cost-effective materials and the manufacturing processes. It allows the manufacturers to optimize their supply chains. They reduce the production cost without compromising the quality. Quality is not compromised here, but the thing is that we can go for some of the some replacement of these materials. Suppose previously I am using sand, I am using the ash, so or something like that I am using. So with the same strength, I am not compromising the quality or the strength. But there is a substitute for that one, which is available plenty in the market that I can use. Then the competitive advantages by analyzing competitors' product. Manufacturers can gain insight that inform their design and marketing strategies, and these competitive analysis can lead to better product offerings and also the market positioning. Right. So this is called the competitive advantage. Advantages. Then is the quality assurance. As I told you previously, the reverse engineering enables manufacturers to ensure that product meets specified standards and also tolerance. So we accept this much of tolerance and all things. Check with your and the existing by comparing product items to original specifications. The companies can maintain high quality output and minimize the defects. That's the thing we cover under this quality assurance. Then the customizations and the personalizations, which already we studied. I'm not repeating that one. Then integration of legacy systems we studied. Then knowledge retention to some extent. Okay, here the reverse engineering preserves valuable technical knowledges about the older products and also technological, ensuring that insights are not lost over time. This is particularly important when original designs and documentations are unavailable. Okay, so that's why this reverse engineering helps a lot. Then training and skill development, we covered all things. Then the sustainability initiatives, the innovative and R&D. This R&D part, you check it here. The insight gained from this reverse engineering can fuel research and development efforts, leading to new technologies, consumption of new materials or substitute materials, and process that derive innovation within the organizations. I don't wait for a scientist to develop something. It is the in-house or the from the system itself, we can get some innovative ideas and we can go for this. It's right. Then any failure analysis and problem solving also can be done using that one. When product fail, the reverse engineering can be used to investigate it, the what is the root cause, right? And by understanding why a product did not perform well as expected, it can inform the future design improvements and also enhance the reliability, right? Then it is the last time we can go for who are the successful reverse engineering, who are the companies or who are the organizations using the smart manufacturing. See, first of all, we can go for the automotive industries. If you see the Tesla's electric vehicle technologies now, everybody will be having idea about this Tesla's, and you will know this Tesla is a great person. You know what is the original research? It was there. So he thought that the entire Earth is just like a conductor, and using no this space, he is able to produce electricity. That is the idea he thought that time. The ionic sphere or whatever things that are cutting calculate there. Anyway, that is a different part, and we are not covering it here. So it was a great idea, and it had never been implemented there. But this Tesla has been known to analyze and reverse engineering components from competitors' vehicle, including the battery technologies and the software systems. And this process has helped Tesla enhance its own electric vehicle designs and software capabilities. So, what is the best with others? He purchase and go for the reverse engineering with a very less time. He can capture and he can go for the enhancement, leading to significant advancements in performance and also efficiency. Then the replacement of some parts, which is very costly or which is not available in the market, that is also possible using this one. Companies specializing in aftermarket automotive parts often use reverse engineering to create compatible and replacement components for older models. By disassembling and analyzing original parts, they can produce high quality replicas that fit and functions well as intended. Then the consumer electronics, see, the Apple's iPhone, Apple has been known to reverse engineer competitor products to understand their technologies and the design features. For example, when designing new features for the iPhone, Apple may analyze competitor or the competing smartphones to gauge performance, user experiences, and design elements leading to innovations in their own devices. People have done already, and world's top companies they have done it. And the smart home devices, the company is developing the smart home devices or a product often use the reverse engineering the existing devices to integrate competing features or improve functionality such as better connectivity or user interfaces. All things are there. So smart home, better now you are here, you forgot to switch off the AC and you are traveling from there through your iPhone or through your mobile also, you can switch off. These are the things that is happening with the smart home devices. Then the aerospace, Boeing and Airbus, all of you know, both companies routinely engage in reverse engineering to analyze parts and systems from competitors or the legacy actor. This process helps them enhance safety, reduce the cost, and also innovate new aircraft designs. For instance, They may reverse engineer the component to understand weight saving measures or the aerodynamic efficiencies. Okay, because while flying, more the weight, no, it will create a lot of trouble, as you know better. So then the industrial machineries, like this our mechanical and metallurgy people, they can better understand the CNC machine or the computer numerical control. The CNC machine manufacturers of the CNC machine may reverse engineer competing products to identify superior technologies or features. This can lead to improved machine designs, better precision, and also enhanced automation capabilities. Most of the colleges also they're using this CNC machine, but they're confining to the aluminum foils. They can do small things, but actually, cost of the original CNC machines is in lakhs, maybe 80 to 90 lakhs for one machine will be there. We need the parts of ports and other things. They can be better done using this CNC machine. When the 3D printers, most of these, universities and institute of national importance, including our it also, they are using these 3D printers. The companies in the additive manufacturing sectors often analyzing the existing 3D printers to identify opportunities for enhancing print speed and material compatibility or user interfaces, therefore advancing their own product offerings. Okay, but even if you want a small model of anything, plastic or anything, using the 3D printers, why 3D? Even if people are going for construction using the 3D printers. Then the medical devices, that is the prosthetic development. Companies creating the advanced prosthetic, often reverse engineering existing design to improve functionality and comfort. By studying the biomechanics of current devices, they can create more effective and user-friendly solutions for patients. Right. Then the diagnostic equipments, like the manufacturers of medical diagnostic devices may utilize reverse engineering to enhance their products' accuracy and reliability by analyzing established devices in that market. Like that, we are having, yeah, I think we have another 10 to 15 minutes with us. Anyway, we'll be going to finish this within the next 5 to 10 minutes. Then the consumer products, like the kitchen appliances, companies may reverse engineer popular kitchen gadgets to identify innovative features that consumers favor. This can lead to the development of improved and user-friendly products that cater to the modern cooking needs. Then the sporting goods also, reverse engineering is frequently used to analyze high performance gear such as athletic footwears or bicycles, allowing companies to enhance design for better performance and also comfort as needed by the customer or the players. Then the furniture design is also another important things. The modular furnitures, the furniture manufacturers might reverse engineer popular modular designs to create customizable solutions that meet various consumers' needs, integrating features that enhance usability and also aesthetic. Right. Like that, what are the industries that are exactly benefited from this reverse engineering in the smart manufacturing? Already most of the things we covered, but still, for 5 minutes we can have a look on these things. The reverse engineering has yielded significant benefits across various industries within smart manufacturing. Here are some of the industries that have notably benefited, like the automotive industries. What I told you, that the companies using the reverse engineering to analyze the competitors' vehicles and also components, leading to improvement in design, manufacturing processes, and also development of the customer parts. Like that, the aerospace, I have already given example how the aerospace people they are using. Then the consumer electronics, the industrial machinery also, this part I have not covered. Manufacturers of industrial equipments and machinery leverage reverse engineering to optimize designs, improve also the automation, and also enhance the performance of their products such as the CNC machines and also robotics. Okay. Then the medical devices, the aerospace and defense equipment also they are able to do. The consumer products they are able to do. And most one of the important thing is the pharmaceutical and also biotechnology. In drugs development, reverse engineering can be used to analyze existing compounds and also formulations, facilitating the discovery of new drugs or the improvement of existing ones. Okay, so this is also it is a great, because it's a situation like the pandemic, no, COVID-19 and all things. So starting a research and doing a lot of things, it consumes a lot of time. testing, and also manpower. And sufficient time will not be there for all this testing. So there, the reverse engineering plays a very crucial role. Then the textile and fashion also. The various fashion brands may reverse engineer successful garments or the accessories to understand the patterns, the materials, and also construction techniques, leading to more innovative designs and also improved product lines. Then the construction and building materials, that is also important for the civil engineers or the people who are the architect in various construction related things. The construction industry can employ reverse engineering to analyze building materials and also the structures, optimizing design for energy efficiency and also sustainability. These are things. Then the energy and utilities for electrical and other people also. For companies in the energy sectors can reverse engineer the equipment and system to improve efficiency, reduce the cost, and also integrate the renewable energy technologies efficiently, right, or effectively. As part of the robotics, which is a major part and a major role we are playing in the automation industry. The robotics industry frequently uses the reverse engineering to analyze robotic systems and the components, leading to advancement in automation and artificial intelligence applications. Then the reverse engineering has significantly improved efficiency in smart manufacturing in several ways. Here are some of the key aspects of how this practice contributes to the enhancement. First one is the process optimization. We understand the concept of optimization. In the process optimization, by analyzing the existing manufacturing process and products, companies can identify inefficiencies or bottlenecks. This understanding allows for the re-engineering of processes to streamline operations, reduce the waste, and also enhance the throughputs. Unit output, we call it throughput. So these things can be better done using the process because number of process is there. What is the best process? That is the process optimization. Then the rapid prototyping, reverse engineering enables quick creation of prototypes by disassembling and analyzing existing products. This speed allows for the faster iterations and testing of new designs, reducing the time required to develop and launch a new product to the market. Then improve the quality control, we covered. Then the cost reduction, obviously, because we are not starting from the scratch, we are going for the reverse engineering, cost will be reduced. Enhanced supply chain management, we covered. Then the customization and flexibility, I already told you that the customization and the personalization, here also flexibility is there. Then integration of new technologies. Reverse engineering helps organizations understand how to integrate new technologies with the legacy system, existing system, old system. And this integration can enhance automation and also connectivity, leading to smarter and more efficient production lines. Then the knowledge retention and transfer, that is also there. Then the reduced downtime. Understanding how components work through reverse engineering allows for better maintenance practices. Manufacturers can proactively identify potential failures and also implement predictive maintenance strategies, reducing equipment downtime. Then the innovations and the continuous improvement is that is there. Then we have got the training and the skill development we covered, the sustainability and resource efficiency there. So we can come here that as technologies continues to advance at a rapid pace, the field of reverse engineering will become increasingly crucial in the IT industry also. With advancement in machine learning and also the artificial intelligence, we can expect to see more automated tools and also the techniques for reverse engineering. Also, reverse engineering will play a vital role in the DevOps, the developer, and like that the company now existing the DevOps. These DevOps practices enabling teams to understand legacy systems, identify the vulnerability, and also optimize the performance. And this proliferations of the IoT, Internet of Things, as I discussed previously, this will bring new challenges, and the reverse engineer or engineering will be instrumental in understanding how these devices operate, uncovering the potential vulnerabilities, and also implementing the necessary safeguards. Ultimately, reverse engineering is a powerful tool that allows us to understand, analyze, and innovate in the face of growing system complexity and matrix. So you see here that one of the AutoCAD, how they are using to design or go for the modeling. and you can see the different areas where they can do data import and reuse. They can for the advanced 3D part design, advanced 3D assembly design, synchronous technologies, model-based definition, MBD, the augmented reality, augmented virtual reality, all the things are there. The sheet metal, we'll study in details about this AR and VR in our next session, right? We'll have 5 to 10 minutes on this AR and VR only. Then sheet metal design, the design for cost, the frame for the frame for weldment design, surface modeling, plastic part design, jig and fixture design, concept. You see all the things, gear design, pull design, all things I can study a lot of time. Take animation, we can go for the mesh data reuse, we can go for the 3D printing, we can go for the advanced state simulations, vibration simulations. So all the things we can do using this thing. Then the techniques of reverse engineering, it can be utilized also in the tiny fabricated chips or more easily in exported layout video files. These chips, reverse engineering, it is analog versus the digital. We can go for the analog and digital. In circuit design, we can distinguish between two very different parts and also worlds, analog and digital. With previous chips technologies, it was easier to retrieve the schematic and the netlist from a chip. The circuits were simpler and also bigger in size. But in 1975, the standard transistor size was 6 micrometer. It begins of the Moore's law. But now, analog circuits are also made 180 nanometer or even lower than that, even if 130 nanometer or up to 7 nanometer. The size is smaller, but also the technologies are more complex with more layers. So function is not compromised, the quality is not compromised, but size is compacted. You know, the VLSI, very large scale integrated, it is same. Analog parts are the most copied because the reduced count of transistors, and it is the lack of effective defense techniques also. Then we go for the next in digital block. On the other hand, that is the analog. Then we are going for the digital. The digital blocks, on the other hand, the number of transistors increases considerably up to millions. You know, some millions of then real estate there. Also, the locking techniques are well developed. It is almost improvable to counterfeit the digital parts. And here, many protect techniques and millions of transistors should be integrated. You see one thing is there, one integrated circuit you can see in the right hand side. These are things it is there. So thank you here, and I think it is the time we can have a couple of questions if people like. Otherwise, we can end the session here. Over to you. Thank you.
Thank you, Professor Gunamani Jena. So now the panel is open for a couple of questions from participants. If anyone is having any queries or any needs any clarification, then sir is there to address you. So there is one question. So how can we protect our product from being, okay, it was text message actually.
Yeah, if you get any difficulty, I have provided my email ID and also mobile number. I'll be open to them also.
Perhaps there is some issue in his mic. So Mr.
Okay.
Manikchand Patnaik is asking, how
Yeah,
can we
yeah, yeah.
protect our product from being reverse engineered? That is the question asked by Manik Chandra.
Yeah, I understand Professor Manikchand Patnaik. He's a computer science professor from Roland Institute of Technologies. Yeah, dear professor, yeah, software things can be protected, well protected, because you are aware about that one, unless it is hacked. But so far, the hardware product is there. Uh, Once it is in your competitor's hand, they can do the reverse engineering. Nobody can stop it. I think what the Chinese are doing, if you fired a missile or any jet engine there in their land, within months, within no time, they can go for the reverse engineering. Yes, it's software related things. You know, this firewall is there, and you are having so many things developed. I understand what is the thing. That can protect it to some extent until otherwise it is hacked. But the hardware, once it is in their hand, they can go for the reverse engineering. There is no way out left to protect. I hope I answered his questions, and thank you for this very good question. Thank you, Professor Manchal.
Uh, any more questions from participants? Jagannath Prasad, sir, are you asking anything? No. Okay then, so thank you so much, Gunamani sir, for accepting our
Yeah, I am
request and delivering
really
such a
thankful. I am really thankful to you all, especially all the delegates and the people who are here. I think a number of people are there. And really thankful to Pete also, and especially this madam, coordinator madam, that is Surekha madam, I
Smith.
think,
Yeah.
Smita madam. Madam, I am very much thankful to you, and I am especially thankful to Mr. Our Rakesh Ranjan Pillai, who motivated a number of faculty and delegates to join, and also our one of our Professor Prajapati in Indonesia also. We are really thankful to them, and will be expecting a number of activities in future in collaboration with KIT. I thank the management. I also thank the chancellor, vice chancellor, and all the various committees involved in conducting this tremendous and excellent program. Because conducting this FDP, it is not a small thing, and this much of participant and a very cooperative and also in a very reactive, interactive manner. So I thank you all, and especially my special thanks to all the delegates and the participants there. Thank you all. I'm thankful and grateful to you. And good night to you all. Thank you all.
Thank you, sir. Thank you all the participants for your active participation throughout this session. And now wish you all a great evening and good night. See you tomorrow.
Sir, thank you, sir. Sir, namaskar. Thank you, sir, for your
Thank
beautiful
you.
deliverance.
Thank you all. Thank you. Yeah.
I'm proud of you, sir. That's like this.
Thank you.
Thank
Good
you.
to
Thank you
see
very much,
Professor
sir, for your
Pole
inspired
sir.
session,
Yeah,
sir. Thank you.
thank you. Thank you, sir. Thank you.